Hello, everybody. Hello and welcome to our new technical webinar. I wish now you can recognize my voice. This is me, Ahmed Al-Garhi. I will moderate this technical session for Engineer Hani Mitwalli. We have amazing session about well control principles and procedures. Before I start introducing Engineer Hani, let me give you some quick tips. First, please, if you have any question, write it down in the Q&A section. We stop chatting because we notice that chatting distracts you. So please focus on the presentation. And whenever you have a question, write it down in the Q&A section. Second, please try as soon as possible to finish registering on Google Classroom because you have quizzes, you have due dates, you need to meet. So please quickly try to figure out what is the problem with your registration in Google Classroom. For sure, we are trying to help many of you, but remember, you are more than 7,000 trainees, so we cannot help you one by one. It will be, a lot of wasting time. So please follow the directions we wrote for you in the Facebook group and try to fix the problem as soon as possible. Now I will introduce Engineer Hani. Engineer Hani graduated from Faculty of Petroleum Engineering in Suez University in Egypt in 2006. Engineer Hani joined the Agiba Oil Company, Agiba Petroleum Company. It is a joint venture with the famous Italian, or you can say multinational company, Eni or Eni. Hani is a supervisor, drilling and workover engineer. For a long time, he gave technical consultations for Saudi Aramco, for Naftogaz, Ukraine, for Kuwait Energy. Right now, Engineer Hani working for Neft Energy company in Saudi as a senior well control instructor. Engineer Hani, now stage is yours. You can start.
Okay, thanks, Dr. Ahmed, for your introduction. And really, I'm very happy today that I will be part of your people or your team to add some value for our students. First, I'd like to introduce myself. My name is Hani Mitwalli. I am a senior well control instructor at Neft Energy Training Center in Saudi Arabia. And I started my career since 13 years. And really, I'd like to add some value for you. And only for one hour, it's not enough to learn well control, but I will give you full view or overview of well control, the main principle and the procedure for well control. So we are ready now to start?
Yes, go ahead, please.
Okay, good. Hello, everyone. Today we have a session of well control. This is the first session of well control. It will be principle and procedures. So please give me your attention for 1 hour only, and I will give you all the details related to principle and procedures for well control. Okay, so by the end of this webinar, you should be able to define some important terms used in well control. Describe how kicks happen. Recall how kick happen. or how we can detect the kick. Identify the first action to take when we have a kick. Describe how to make the well safe. Also, recognize the key rules and responsibility during kick. So, my webinar today, it will be 5 sections. First section will be basic definition. Second section will be how kicks happen. Third section will be monitoring, detecting, and first action. Fourth section will be making the well safe. And last section will be rules, responsibilities, and empowerment. Okay, before we start, we need to ask why you need to learn well control during drilling operation. This is very important to start our session today. Actually, we need to learn well control to save ourselves, to save our people, to save our equipment, our company assets. All of this reason to learn well control. So let's start from section number 1. We will define some basic terms like well bore. What is the meaning of well control? What is the meaning of hydrostatic pressure, formation pressure, bottom hole pressure, overbalance, underbalance, influx, blowout, and tripping. All of this will cover through the first section. So let's start from well bore. I will start from the point with Dr. Mustafa yesterday. Dr. Mustafa start the webinar and define that we have open hole section and we have cased hole section. So during drilling operation, you will have open hole section. Still, you have to drill this section. And already we finished drilling the first section and the case of using casing. So what is the meaning of well control? Actually, during operation, you will have pressure from the formation, and we need to control the formation pressure. So again, we need to keep our operation under control. This is the meaning of well control. As you see, we have a flow, so we need to control the formation. How we control the formation? Mainly, we will consider the primary barrier, the primary defense line will be our drilling fluid. So take care. Our drilling fluid will be the primary defense line, primary barrier. But in case we lost our primary barrier, what we'll do? We will have another option. It will be the secondary barrier, the pressure control equipment. Whatever we talk about POP, we talk about during service operation, but we have secondary barrier. We have backup barrier for the primary one. So this is a lesson we need to learn, that we have primary barrier, which will be the drilling fluid, the mud, and also we have secondary barrier, which will be the pressure control equipment. Even during production, still we have well control. How? Because we can consider the Christmas tree itself a pressure control equipment. Even during well service operation, if you will perform coil tube operation, wireline operation, all of this will be under control using pressure control equipment. But today I will be focused on the well control during drilling operation. Okay, so we consider the primary barrier is our drilling fluid, and secondary barrier will be the pressure control equipment on location. But to be clear with you, the pressure control equipment, we need it to be ready, we need it to be certified to fit the purpose of the operation. So if we have pressure control equipment on location but not certified, not tested, we cannot consider, in this case, the pressure control equipment as a barrier. Also, we consider the people on location is a vital part of our pressure, our well control. So we have to keep our people trained and provide their job as a good job. And also last, we consider that the prevention is better and easier than cure. So if we can control the well, no need to go to kill and we lost people or assets or equipment. First, we need to describe what is the meaning of hydrostatic pressure. I consider the first section of my webinar today will be foundation for your well control career. So what is the meaning of hydrostatic pressure? Actually, hydrostatic pressure is not 2 words. It is 3 words because we consider hydro is the first word, which is fluid. It means fluid. Static, it means rest or not moving. Pressure. So we can define the hydrostatic pressure is the pressure of the fluid at the rest. The pressure of the fluid at the rest. It's okay. So from where we have a pressure, because we have a fluid exert force. And as I start today, that the primary well control barrier will be the drilling fluid. So the drilling fluid will create hydrostatic pressure. Why we need the hydrostatic pressure during the operation? Because actually the hydrostatic pressure will control the formation pressure, will keep the formation pressure under control. Okay, let's start, take example. We have a couple and we have a cup of water, and in this case, if we can install pressure gauge on the bottom, you will record the pressure. Why? Because the fluid weight will create force on the bottom, and in this case, the force act on the area, so we will have pressure. Same like we have submarine, and as we go deeper and we record the pressure, also you will find the pressure increase. Why? Because the depths increased. So in this case, we consider the height of the fluid is a factor effect on the pressure. So for this reason, we need to consider the height of the fluid. It is very, very important to know the height of the fluid. And if we talk about our drilling operation, the depth of the fluid. Other factor will be the density of the fluid, the weight of the fluid, also will affect on our pressure. So again, we have the first factor will be the height of the fluid, and the second factor will be the fluid density. As the fluid density increased, the pressure also will increase. Why? Because the force exerted on the bottom will increase by increasing the fluid density. Let's take example to be clear for everyone. We have a container with volume 1 gallon, and we put inside the container fluid with density 10 ppg. What is the meaning of ppg? Pound per gallon. So we have a density of the fluid 10 pound per gallon. We can calculate the weight of 1 gallon of the fluid, because we have a fluid density 10 pound per gallon, and we need to calculate the weight only for 1 gallon. So in this case, it will be 10 pounds. And we define the pressure as a common, as a general definition, that the pressure is a force act on area. So in this case, we need to calculate the area of the container. For example, we have the area of the container 10 inches square. So very easily now to calculate the pressure on the bottom. The pressure on the bottom will be the force act on the area. So it will be 10 pounds divided by 10 square inches. So it will be 1 pound per square inches, or PSI. So now we are familiar with our pressure unit. What is the meaning of PSI? Pound square inch, force over area. Okay, we have another example. Remember, first example, we have fluid density 10 ppg. let's talk about fluid density 15 ppg. So in this case, we increased the fluid density. We need to learn what is the effect of the increasing of the fluid density on the pressure. So again, the weight of 1 gallon of fluid will be 15 pounds. How we can calculate the pressure? I think now we are familiar. So the pressure will be force over area, 15 pounds divided by 10 square inches. So the pressure on the bottom will be 1.5 psi. So as you see now, as you increase the fluid density, the pressure will increase. Okay, now we have another factor. The depth, the height of the fluid also will affect on our pressure. As the depth increased, the pressure on the bottom also will increase. So take care, because once we start talking about why we have whole control accident, we will talk about the level of the fluid. Sometimes we can describe the pressure as a pressure gradient. So what is the meaning of pressure gradient? Actually, we can consider the pressure gradient is an increase of the pressure per 1 foot. So the pressure gradient equal psi per 1 foot. That's the meaning of pressure gradient. And if you have pressure gradient, you can calculate the pressure at any depth, because once you have a depth, you can multiply the pressure gradient by the depth. Okay, here we have example for the pressure gradient. For example, fresh water. Fresh water pressure gradient equal to 0.433 psi per foot. I see someone asking, from where will you bring this number, 0.433? Friendly, this is very easy to calculate the pressure gradient. Once you have pressure or fluid density and multiply the fluid density by 0.052, you will get the pressure gradient. But take care, from where we have 0.052. Actually, it is conversion factor to convert pound per gallon to psi per foot. So for example, the freshwater density 8.33 pound per gallon. So multiply the fluid density, the freshwater density, by 0.052, you will get the gradient of the freshwater, 0.433 psi per foot. And why we need to learn what's the meaning of hydrostatic pressure? Because we need to control the formation pressure. So what is the meaning of formation pressure? It is the pressure of the fluid inside the rock, within the rock. As yesterday also, Dr. Mustafa described what's the meaning of porosity and the permeability. So in this case, we have a fluid inside the formation, and we need to consider that the fluid under pressure. So the formation pressure is the pressure of the fluid inside the formation or within the pore space. So we need to control the formation pressure using the hydrostatic pressure of the drilling fluid, mud. Okay, but if you lose your control for any reason, what will happen? You will have blowout at surface. Okay, now we have example also. We have a container and we will start to fill up the container with water. The container height 1 foot and we install pressure gauge on the bottom. So now my question, what is the pressure gauge record if we fill up the container with fresh water? And remember, the height of the container only 1 foot. Let's start. Okay, now we fill up the container with fresh water and we record the pressure. What you will get? You will get 0.433 psi. Why? Because remember, we start talking about the pressure gradient for the fresh water, 0.433 psi per 1 foot. So in this case, very easy to calculate the pressure. It will be the height of the water multiplied by the pressure gradient. So in this case, we have 0.433 multiplied by 1, it will be 0.433. So in this case, we have a pressure 0.433. We have another example. We have another container with the same volume, and we will put some plastic pool inside the container. Okay, this is like the formation. We have some grains. And also we will start to fill up the container with the fresh water. What do you think? You will record the same pressure on the bottom or not? Remember, the volume of the water is the same, but part of our water will spill out because we put inside the container many balls. So as you see, we have the same pressure on the bottom. Why? This is not logic. Part of our water outside, why we have the same pressure? Because actually the pressure doesn't depend on the volume. So this is a new lesson today. The pressure only affected by the height of the fluid and the density of the fluid. So the volume of the fluid doesn't affect of the pressure. Now we are familiar with the hydrostatic pressure, with the formation pressure, and what is the factor effect on the pressure. But remember, we start talking about hydrostatic pressure, the pressure at the rest. But if we start to pump, what we will have? Actually, it will not be hydrostatic. It will be bottom hole pressure. So what's the meaning of bottom hole pressure? This is a total pressure will act on the bottom of the well. Total pressure will act on the bottom of the well. And mainly we consider the pressure loss on the annulus will affect on the bottom. So we consider the APL or annular pressure loss will be part of our bottom hole pressure. So we can describe the bottom hole pressure during circulation equal to the hydrostatic pressure of the fluid plus the annular pressure loss, the pressure loss in the annulus side. And again, if we circulate the hole, but we make some or choking on the surface, we have restriction of the flow. So also, again, the restriction of the flow will act on the bottom. So in this case, the restriction will affect on the bottom hole pressure. So the bottom hole pressure will be higher than normal. But actually, how we can monitor the bottom hole pressure during drilling? We have many techniques, but mainly here we have pressure while drilling. These downhole tools, you can install it downhole and record the equivalent circulating density, the equivalent density on the hole during pumping. This now example that during pumping, you will have hydrostatic pressure. Try to control the formation pressure. The question now, what is the relation between formation pressure and hydrostatic pressure? Now we have two factors effect on the bottom, hydrostatic pressure and formation. But what is the relation between formation and hydrostatic? Actually, if the hydrostatic pressure or if the force exerted by the drilling fluid will be higher than the force exerted by the formation fluid, in this case we are overbalance. Again, overbalance, it means our hydrostatic pressure higher than the formation pressure. And actually, this is our concern. We need to be overbalanced during drilling to avoid any well control case. But if we lost our control, if the force exerted by the formation is higher than the force exerted by the hydrostatic, in this case will be underbalanced. And take care, once you are underbalanced, it means you will get a kick. For example, now the hydrostatic pressure, as you see, started to decrease. Why? We will learn on the second section. But now the hydrostatic pressure decrease. What will happen? You will have a kick because the hydrostatic pressure less than the formation pressure. Okay, for example, now we have the formation pressure equal to 5,000 psi. And our true vertical depth, our hole depth, 10,000 feet. We started to drill our section using 10 ppg. This is our mud density, 10 ppg. So very easy to calculate the hydrostatic pressure. The hydrostatic pressure, it will be 0.052 multiplied by the fluid density multiplied by the depth. So in this case, the hydrostatic pressure equal to 5,200. I think it is clear for you that you are overbalanced by 200 psi. Hydrostatic pressure over the formation pressure by 200 psi. But if we replace our density, our fluid to be water, fresh water, and the fresh water density 8.33 ppg. Let's check we are under balance or we are over balance. By calculating the pressure on the bottom, you will find that the bottom or the hydrostatic pressure will be 4,330 psi. It means we are under balance. Why? Because the hydrostatic pressure less than the formation pressure. So I think now everyone familiar with the overbalance and underbalance terms. So actually we have three relationships in between formation and the hydrostatic. First one, overbalance. It means the hydrostatic pressure over the formation pressure. Balance, the hydrostatic pressure of the fluid equal to the formation pressure. And the last one, the underbalance case if the hydrostatic pressure less than the formation pressure. Okay, what is the meaning of kick or influx? Actually, if we have an influx, it means we have unplanned, uncontrolled, undesired entry of formation fluid. And the formation fluid can be water, gas, or oil. So we have unplanned entry of water or gas or oil on the bottom. Remember, influx is still on the bottom. And the size of the influx is a very, very important. Once we have an influx and we need to control the situation, we need to consider the size of the influx will affect on our well control operation. Okay, what will happen if we didn't take any action? We have influx on the bottom and we didn't take any action. What will happen? You will have blowout. So what's the meaning of blowout? It means we have uncontrolled flow of the formation fluid into the wellbore, but it reached to the surface. So in this case, we have big problem. We have a blowout. So what's the difference between blowout and influx? Same. We have uncontrolled, undesired, unplanned flow on the bottom. This is the influx. But once it reaches to the surface, it will be blowout. Sometimes we have blowout on the bottom. That it means we have underground blowout. So what is the meaning of underground blowout? It means you will have formation fluid flow from interval or from the formation to another formation. As you see here, we have formation flow passing from this interval, from this formation to the other formation. This underground blowout. And believe me, after you have underground blowout, you will have surface blowout. This is a problem. So we need to consider underground blowout. New term we need to discuss. What is the meaning of tripping? Tripping. Tripping, it means you will pull out or you will run with your string in the hole. But why we need to pull out of hole with our string? You can finish your drilling operation, you reach your depth. So in this case, we need to pull out of hole, or we need to change our bottom hole assembly. We need to replace our bit because the bit teeth worn. So in this case, we need to pull out of hole. What is our concern of tripping? We consider the tripping operation is the most critical operation on the site. Why? Because we record the most well-controlled problems during tripping. Once we started to pull out of hole with our string to change the bit, to change the PHA, what is the reason that we retrieve our string from the hole, and during retrieving the string, we didn't take care of fluid. We need to fill up the hole with the fluid, with the metal displacement of the drill string. In this case, you can lose part of hydrostatic pressure. So the tripping is one of the most critical times of well control because the mud is not being circulated. During tripping, we will stop bumping. So the mud is not being circulated and the bit is not at the bottom of the well. So what we have to do, we need to pump equivalent volume of the metal displacement of the pipe retrieved from the hole. Section 2. Now we have a foundation to understand well control. Section 2 will be how kicks happened. How kicks happened. It can be due to some reasons. For example, abnormal formation pressure, failure to monitor the well, failure to keep the well full of mud, incorrect fluid density, swabbing while tripping, low circulation. Please don't worry, we will discuss all of this during the section. So, how kicks happen? We consider the kick is the flow from the formation into the wellbore. So, we have a flow, we need to take action. So, our action will depend on the performance of our crew and also the equipment on location. So, all well-controlled equipment must be in perfect working order and the crew fully trained. If we start talking about how kick happen, we need to consider the kick will happen if we are under balance. So again, if we are over balance, we control the formation pressure. If we are under balance, we will have kick. So the hydrostatic pressure decreased or the formation pressure increased. The same idea, we are under balance. So what is the main reason that you will be under balance? First one, we have abnormal formation pressure, failure to monitor the well, failure to keep the well full of mud. It can be we use incorrect fluid density. We have swabbing while tripping, or we have loss of circulation. So let's start one by one. Abnormal pressure. From the beginning, we started to plan for the drilling operation and we use the correct fluid density. But we surprised that we have formation pressure abnormally. We have abnormal formation pressure. In this case, we cannot control the pressure. Number two, failure to monitor the well. Remember, during drilling operation, we have to keep monitoring the well all the time. For example, we need to monitor the return flow from the well. How many barrels we pump, how many barrels we have a return. But if we have a failure on our monitoring devices, in this case, you will get a kick at any time without any message, without any warning sign. Also, another problem of kick, it will be that we fail to keep the well full. Again, during tripping out, we need to fill up the hole with a mud. equivalent to the metal displacement of the drill string. So if we didn't fill up the hole with the mud, what will happen? The level of the mud will decrease by the time. And at certain time, you will have drop in the hydrostatic pressure and you will get influx. So the space left by the drill string is being removed, has to be continuously replaced by drilling fluid. But if it doesn't happen, you will have a kick. Or you will have a blowout if you didn't take your first action to control the well, shut in the well. For example, here we have a tripping and we didn't fill up the hole and the level of the mud started to decrease. So the hydrostatic pressure decrease till you get kick. So remember, we need to monitor, we need to fill up the hole during trip out. Also, another reason that you have kick, that you work with incorrect drilling fluid density. What is the meaning of incorrect drilling fluid density? The fluid density in this case, it can be higher than planned or higher than required or less than required. If the fluid density is higher than required, what will happen? You will have loss of circulation. But before we talk about the density of the fluid higher than or less than required, we need to monitor, we need to record, we need to measure the fluid density on the rig using many devices. For example, we have mud balance. But remember, mud balance is not only the device to measure the mud density. We have another devices, but the common device is a mud balance. So if the weight is too great, is too large, higher than required, what will happen? In this case, you will damage your formation and also you will cause formation loss or loss of circulation. If the mud density is not enough to control the formation pressure, you will get kick because you will be under balance. So now we start our operation as normal, as you see, and we have bottom hole pressure higher than formation pressure. So we are on the safe side. But take care. During drilling, okay, we have monitoring device on the flow line, on the return from the well. So we monitor the percentage of the flow. For example, now we have 50, but still start to decrease. What is the reason? We have loss of circulation. As you have loss of circulation, you will lose part of your fluid through the formation. So the return will be less normal. We decrease, we lost our return. What will happen? Yeah, the bottom hole pressure is still over the formation, but by the time you will lose the bottom hole pressure. In this case, you will get influx. What is the indication on the surface? As you get influx, the gas will start to migrate up. And as the gas migrates up, it will displace the fluid to the surface. So in this case, the gas migrated up and the return will start to increase. We have a big problem, my friend. The return increased from the formation. It is not our return. It is the return from the formation because we have a kick. At the time, you will have alarm that take care, the flow increased and we need to take our action. Okay, this example of swabbing. What is the meaning of swab? It means we retrieve our drill string very fast and our clearance in between the drill string and the annulus is very small. And also the viscosity of the mud is very high. So in this case, what will happen? You will have swabbing. What is the meaning of swab? It means you will make like piston effect on the formation. You will make piston effect on the formation, so you will swab the formation fluid. So the hydrostatic pressure will decrease till you get kick, till you get influx, formation fluid. Another reason that you will have kick or influx, that you have loss of circulation. Why we have loss of circulation? Because the density of the fluid is higher than required. So in this case, we lost part of our fluid through the formation. Or we drill through depleted reservoir. And as normal, during drilling, we monitor, we record the volume of the mud, of the drilling fluid on the mud system, so we can keep our operation under control. But if you have loss of circulation, what will happen? You will lose your barrier, your hydrostatic barrier. This one, for example, here we have loss of circulation through depleted reservoir. So in this case, you will lose your hydrostatic head. The level of the mud will decrease, so you will get kick. Now we are familiar with all reasons or the most common reason of kick. So the second or the third section will be how to monitor, to detect, and what is the first action we need to take if we have a kick. We will discuss in this section the kick warning sign. What is the meaning of kick warning sign? Kick indicators. What is the first action we need to take? How we can shut in the well. How we can control the well if we have a kick. So first, the well people or the crew have to recognize the kick very fast, very quick to control the situation. Then we need to take our action to close the pressure control equipment, shut in the well. So in this case, we have a flow. We don't have enough time to discuss, to talk, to have a meeting. We need to take the first action to shut in the well, close the well. And how we can know that we have a problem? You will have warning sign. The warning sign, it is like message from the formation. We have a message from the formation that we are under balance. The most common warning sign or the message from the formation will be the return mud flow. As the return flow increased, it means we have flows from the formation. So the flow rate and the mud volume, it will be the first indicator that we have a kick on the bottom. Again, the well will talk to you. You have just got to be prepared to listen to it. We consider the warning sign message from the well. So please take care and listen to the well. So what is a warning sign? Mainly, we have two operations during drilling. It can be tripping or drilling. Sometimes we need to trip out to change our bit, to change our bottom hole assembly. So what is the warning sign during tripping? If you trip out, you remove your drill string from the hole. So the warning sign in this case, it will be the hole is not taking the correct amount of fluid. For example, we calculate we need to pump 2 barrels per 10 joints. So once we remove 10 joints, we need to pump 2 barrels. But if we start to pump and only we pump 1 barrel and the hole is full, it means the formation starts to flow. Also, if during tripping in, the hole is not giving correct amount of fluid. During tripping in, we calculate that we will have a return 2 barrels per 10 joints, but actually we have more. In this case, we have warning sign of kick during tripping. What about drilling? I consider or I think that drilling warning sign is very clear because all the drilling parameters will increase. For example, the rate of penetration, how many feet we drill per hour. If we drill 30 feet per hour and suddenly the drilling rate increased, it can be due to kick. We have a warning sign of kick. So the rate of penetration increased. Also, during drilling, we need to monitor to check the cutting size and the shape of the cutting. If the cutting size and the shape of the cutting increased or changed, in this case, it will be warning sign that we have a kick. Remember, all of this message from the formation. Also, during drilling, the torque increased. So it will be like warning sign. Also, we have a sensor of the temperature on the flow line. We record, we monitor the temperature of our return. So once you have increase on the temperature, it will be warning sign of kick, because abnormal formation pressure, with abnormal formation pressure, we have high temperature on the bottom. So if the temperature on the bottom increase, you will have indication at surface, and in this case, it will be warning sign. Chloride content, salinity. Also, the mud engineer on location takes sample of the return and perform some test on the location and measure the chloride content on the mud. If the chloride content on the mud increase, it can be warning sign of kick. The gas content. We consider the risky or the dangers. Kick is a gas. So if the gas content on our fluid increased, it can be also warning sign that we have kick. Last one, shale density. The shale density will decrease if we have a kick. So it is very easy to remember that almost all the drilling parameter will increase, but only the shale density will decrease. The shale density will decrease. Kick indicators during tripping. What is the meaning of kick indicator? It means we have a positive warning sign. So during tripping, kick indicators can be, we have excessive flow from the well when tripping. So the flow, still we have a flow during tripping. Remember, once we start to trip out or trip in, we stop pumping. So if you have a flow, it means the flow came from the formation. What is the kick indicator during drilling? You will have increase on the return from the well. You will have increase of the rate of penetration. You will have increase on the bit volume. The level on the mud tank will increase by the time because we have flow from the formation. And as we consider the kick is a gas, so the gas is less density than the fluid in the hole. So in this case, the pump pressure will decrease. The pump pressure will decrease, and you will find the pump strokes, the pumping rate will increase by decreasing the pump pressure. Now we stop the pump. We have a problem, so we stop the pump. After you stop the pump, shut down the pump, still we have a flow from the well. So this is an indicator. This is a positive sign that we have a kick. So we can make it like summary. What is the positive indicators of kick? We have a flow from the well with pump off. So shut down the pump and still we have a flow. Or during pumping, the flow from the well increase. And the level on the tank, the bit volume, we have again. All of this warning sign and indicators. What is the first action? We need to take our action now. So the warning signs show that we have change in downhole. We have a problem downhole. We need to take our first action. And we consider the kick indicators are positive signs. The first action will be shut in the well, close the well. Don't keep the well open, because as you will keep the well open, you will have more influx. You will get more influx. So we need to close the well. As you close the well fast, you will control the situation. So in this case, close the well. How we can close the well? Using pressure control equipment. It will be another webinar next week talking about pressure control equipment. Who will take the first action? This is a very, very important. Now we have a problem. Who will take the first action? The first action will be from the driller. The driller has the authority to take the first action, to shut in the well at any time. After that, he will check that the well is secured. We don't have any flow. We don't have any leak at surface. Everything is okay. We secured our well. Then he will contact with the supervisor that we have a flow and I control the situation and we need to start take the second action. Okay, so how we can shut in the well? Now we know that the driller will take the first action, but we need to understand how the driller can take or how the driller will control the well. First, the driller will stop drilling or trimming operation. Number two, he will close the pressure control equipment. He will close the pressure control equipment. And he will open the flow through the choke. What is the meaning of the choke? Also, it will be part of our next webinar. But the choke is a device to control the flow because we need to confirm that we have a flow or not. So we will divert the flow through the choke into small tank. This small tank is a trap tank to monitor the flow. So if we have, for example, half barrel, you can catch the flow. If we have a flow, close the BOP or the pressure control equipment already closed, close the choke and control the well, then start to prepare for killing. And to be clear with you, the sequence of the operation or of the controlling the well is different between company to another company. For example, here in Saudi Arabia, we work with Saudi Aramco, so we have policy. So before start the drilling operation, we have a policy. Everyone knows what is the action in case we have a kick. If we work with another company, for example, we work with BB or we work with NI, you will have policy of these companies. But again, the first action is very important to take it at the very fast, very quick, because if you wait, sometimes the flow can reach to the surface. Like here, you see, we have a problem, we have a flow. This is our pressure control equipment. We have kill line and the choke line to pump from the kill line, and also we can take the return from the choke line. The driller now will take his action. We have a flow, so the driller is ready to take the action. He will close the pressure control equipment. He will shut in the well. The driller has pressure control unit, remote panel at the rig floor, so he can close the well. Then he will turn on alarm that everyone on the location will be knows that we have a problem and we need to take our second action. Okay, now we control the well. We close the well, we shut in the well. What is the next? We need to make the well safe. How we can make our well safe? We need to kill the well. Killing, it will be in 2 steps. We need to remove the influx out, the kick, and we need to circulate the new drilling fluid. Actually, we have many killing methods. We have weight and weight, we have a driller, we have volumetric, we have concurrent, we have low and bleed, we have many killing methods. But mainly we talk about we need to remove the influx, we need to circulate new drilling fluid. Because now we have a problem, we have a kick. So we need to remove it, then we need to restore the primary. How? We need to pump another mud, another drilling fluid heavier than old one, so we can control the well. So what we will do, we will make some calculation. So before start killing operation, we need to make some calculation. This one is a kill sheet. This is a common kill sheet. Everyone work on the oil field, he handle or he is familiar with the kill sheet. The kill sheet, it means we have some calculation, how many barrels we need to pump, what is the pressure, everything related to killing, it will be inside the kill sheet. So we need first to calculate the mud weight, the density of the fluid, and also the volume of the mud and the pressure during drilling, during killing. All of this will be through pressure control equipment, BOP, blowout preventer. And what is the main reason or what is the main purpose of killing? We need to get the well back to the stable condition because now we are under balance and we need to resume our drilling operation at overbalance condition. So first, the formation influx must be removed from the wellbore. We need to remove the influx out. Second, we need to pump the correct density because remember, what is the problem from the beginning? From the beginning that the density of the fluid is not enough to control the formation pressure. So in this case, we need to replace or we need to pump another fluid, heavier fluid that can control the formation pressure. How we can pump or from where? We will pump our fluid from or through the drill string, the pipe, up to the annulus side. And during killing, we will use many equipment, pressure control equipment. For example, we will take our return through choke manifold. So the return from the well will be through a choke manifold. Why? Because we need to control the pressure. We need to control the flow. So it will be through choke manifold. But remember, our return will be mud and the kick. The kick is gas. So in this case, we need to separate the gas out. So we will use mud gas separator to pump or to separate the gas out of the well. What about our fluid? We will make our fluid return back to the pit, to the mud system, that we can use it again. So the circle for the operation will be the return through choke manifold, and we have gas with mud, so we can separate the gas from the mud using mud gas separator. Then take the return of the mud on the system and we can pump again. What is the meaning of what is the function of the mud gas separator or the choke manifold? It will be part of our next webinar. And before starting pumping the kill fluid, we need to confirm that our kill fluid able to control the formation pressure. Then you are now ready to open the well and resume your drilling operation because we remove the influx out and also we restore the primary barrier, the hydrostatic pressure. For example, here I bring driller killing methods. Driller killing methods. In this case, we will pump first to remove the influx and we will use the same fluid in the hole. So the first circulation will be to remove the influx using the same fluid in the hole. Then we will pump the second circulation to restore the primary well control. How? We will pump another fluid, heavier fluid, kill mud weight. Okay, now we have the first circulation. So the pressure now for 400 psi in the casing and 300 on the drill pipe, and we're gonna start to pump the current mud weight only to remove the influx. So take care, the influx will be on the red. So this one is the influx, gas. Now we remove the gas out. As we remove the gas out, okay, we pump our original mud. We pump our original mud through the pipe into the annulus through the choke. Completely now we remove the influx. So how we can indicate, how we can check that we remove the influx completely out? The pressure after the first circulation will be same on the casing side and also on the drill pipe side. So remember, before start first circulation, we have casing pressure 400 psi, and we have drill pipe pressure 300 psi. But after first circulation completely finished, we have 300, 300. So we remove the influx. But the question now, why still we have a pressure? Because we are still under balance. We need to pump our kill mud. So the second circulation will be to pump the kill mud. Now we start to pump kill mud, the heavier mud, so we can pump our mud to restore the primary. So as you see, the pressure on casing side and drill pipe side after we finish the second circulation will be 0. It means we are over balance, we control the formation. Now we control the well and we can resume our operation. Last section will be rules, responsibilities, and empowerment. And mainly here I will discuss the main rules and the responsibility for the drill crew. And the drill crew consists of driller, assistant driller, derrickman, roughneck, or roustabout or foreman. So what is the main rules or responsibilities of the crew during killing operation? Again, we are teamwork. So everyone will act as a vital part during well control operation. So we can start from the driller, the big boss on the location, and his assistant driller. Also, he have another operation, and derrickman who will work on the mud system to monitor the return, to record or to measure the fluid density, and the roughneck, the floor hand on the rig floor. So the driller first, he will monitor all the parameters during drilling operation or during killing operation. So we need to keep our driller trained and able to control or to manage the operation 100%. And he will take the necessary action if we have a problem. So remember, the driller has the authority to control, to shut in the well at any time without waiting any instruction from anyone. Here we have our driller. His operation is not easy. All the time, monitor the pressure, record the parameter, and inform the supervisor if we have a problem. So it may be you see something out of ordinary at the rig site, and instead of just ignoring it, you must report. So again, sometimes we have something, it's not like we have a big problem. Please take care. Report to your supervisor you have something, because it can be a reason of you lost your life or you lost your assets. Also, it may be that someone working on the logistics goes to the extra mile to ensure that the correct people and equipment arrive on site. Here we have the teamwork. Everyone work as a team and everyone knows the responsibility for him. This, for example, this is a roughneck or the floor hand work on the rig floor. So what is the meaning of empowerment? Empowerment, it means you have to give the authority to the people to take the action after you train your people. So you need your people trained and ready and qualified to control the situation. And as we consider, the human factor is the main part of our business. And as we discussed how the well control accident or incident are caused, we need to keep our people fit for the operation. So the human factor here refers to the interaction of individual with each other, with facilities and equipment, and with management systems. So last, human factor is an essential component in the effort to operate in a safe and efficient manner. Areas where human factor has a key role include efficient decision making, teamwork in stressful or critical situations, safely culture, and safely behavior improvement program. So human factor include situation awareness, decision making, communication, teamwork, leadership, and managing stress and fatigue. Again, shaker hand. We discuss what's the main duties of the driller. Shaker hand also, he will catch the first sign of kick on the location because the cutting size will change, the cutting volume will change, so it will be sign of kick. And he need to inform his supervisor that we have a problem and we need to take our action. Thank you, and I wish you all the best in your career, and I wish I add something to you today and I didn't lose your time. Thank you, everyone. Thank you, Dr. Ahmed.
Thank you, Engineer Hani. Really, it was clear and comprehensive. So let's get some questions. But before we start getting some questions, let me announce something very quick. Guys, many of you are upset and asking about we don't find enough space in Zoom, so we attend through YouTube. Is this will affect your attendance sheet? The answer is no. Please, the main weight, listen everybody, the main weight of attendance will be submitting your quizzes on time. We understand that we have a room for only 1,000 attendees in Zoom, so we cannot, punish you for that. I mean, it is not your mistake, it is not your problem. So please just try to attend on Zoom. If you did not find a spot, quickly go to YouTube and attend your lecture. Try to communicate, try to write comments on YouTube. We would like to read your comments, but this will not affect your grade. So there is no reason to feel sad about that. Okay, so we got many questions. So the first question, someone asking about, you told us something about the mud is static or mud is not static. You believe mud is not static, and for sure mud is circulating. And he's asking, maybe, I mean, he want to ask about the ECD. What is the difference between the circulating density and the static mud in the wellbore?
Actually, this is a good question, okay? Because to understand the bottom hole pressure, we need to be familiar with the ECD. So while static, the density of the fluid will be like normal. If we work with 10 ppg, it will be like 10 ppg. This is static. But once we start to pump, the pump will make additional force. And we describe the pressure from the beginning is a force act on area. So as the pump starts, it will make additional force on the bottom. Actually, if we make it like in details, once we start to pump, we have pressure loss system. So we have pressure loss on the drill string. First, we will start from the surface line. We have pressure loss in the surface line. We have pressure loss in the drill string. We have pressure loss through the nozzle of the bit. We have pressure loss in the annulus side. And actually, the annulus side pressure loss only will affect on the bottom. So, for example, if we consider the annular pressure loss 100 psi, and in this case, we talk about the bottom hole pressure during circulation equal to the hydrostatic pressure plus the annular pressure loss. So the equivalent circulating density, it means the actual density in the hole during pumping, because 10 ppg, this is only due to hydrostatic. But what about annular pressure loss? Annular pressure loss is a pressure, and also we can convert the pressure to pound per gallon. So in this case, you will have additional force, additional ppg. But once you stop your pump, shut down your pump, you will be able to record the bottom hole pressure equal to the hydrostatic. So again, what is the meaning of ECD, or equivalent circulating density? The actual density during pumping. And the bottom hole pressure during pumping will be higher than the bottom hole pressure during static because we have annular pressure loss.
Okay, thank you very much for this answer. The second question is, are you willing to share a PDF file from your presentation? I know you need to take a permission from your boss,
Yeah,
but tell us.
Yeah, let me take a permission from a training center here in Saudi Arabia, but I think we don't have any problem if it will make add value for our people.
Okay, perfect. So whenever we receive that, we will post it in Google Classroom for our trainees. Okay, I have a question from, maybe it is like a complicated one. Someone asking about the relation between porosity and permeability and the pore pressure.
Okay.
He's asking the pore pressure, is it affecting the the porosity and permeability?
Okay, good. This is a good question also. When we started to study the well control, we have the concern to study also the formation properties. And mainly we study the formation porosity and the formation permeability. We consider if we have very poor permeability, the occurrence of the cake will be less. Because what is the meaning of porosity? It means we have void space in the rock. The amount of void space in the rock is a porosity. But the void space, we need it to be connected. So in this case, we talk about permeability or the ability of the formation fluid to move through the rock. In this case, if we have high permeability, you will have high or fast flow from the formation. So the permeability will affect on our well control operation. And as we have porosity, we will have also hydrocarbon.
Okay, thank you very much for this answer. The next question is someone asking, do we need to add the atmospheric pressure to our equations we are using?
No, because we consider, again, from the pump, for example, if we start to pump and the pressure on the pump is 3,000 psi, if we can install pressure gauge on the return at service, the pressure will be atmospheric. It will not affect on our system. Actually, during pumping, we're affected by the hydrostatic pressure, the annular pressure loss, and if we have any restriction during pumping, also it will affect on the bottom. For example, if we take our return through the choke. So in this case, the pressure on the choke will affect on the bottom, but the atmospheric pressure will not take on our consideration.
Thank you very much. And the following question, someone asking about the accident in Gulf of Mexico, the Deepwater Horizon. And I believe it is a good title. I will try to find someone involved in the accident to give a whole lecture, because it is not something easy to summarize in 1 minute. But if you have something quick about the Deepwater Horizon accident, what was the list of mistakes?
Okay, good. Inshallah, after finish the session, I can send you the investigation of this accident. I have the investigation, the real investigation, not from the movies on the YouTube. Okay,
perfect.
What is the main reason on the investigation that after perform cement job, they have to perform testing on the cement, the negative test, and in this point, some discussion from the rig supervisor and the turbosher and the cement company, it will make big problem and confusing. What is the reason that we have some pressure on the gauge? But you to be familiar or to be on the actual case or what is the main problem, I can send you the investigation of the problem. You can take it and you will be familiar what is the problem and take it like lesson learning.
I believe Halliburton will not be happy to hear about a cement problem because he did the cement for the job, right?
No. This is not Halliburton. This is not BP. We talk about the incident to take a learning lesson. This is not. Now we didn't talk about BP or Halliburton.
So
of work control, it can happen anywhere.
Okay, so also I have a good contact. The guy who wrote a book about the whole truth. The famous book about the Deepwater Horizon. I will check with him if he is willing to give a technical webinar about that accident. Exactly.
It will go the chance, yeah. It will go the chance.
Okay, so the last question, because we already run out of time. So someone asking how to act when there is a continuous loss of mud fluids in the formation. So what
Okay.
would be the, yeah, how to
Okay.
act?
Also, this is a good question. First, once we have fluid loss, we need to fill up the hole with water or any lighter fluid to check if we can decrease the fluid density, so we can avoid the pressure, or we can avoid the loss of circulation, and also in the same time we will be able to control the formation pressure. But if we have complete loss, we have many options. First one, you can pump loss of circulation material. Try to bridge the formation. Second one, if we lost or if we not success to cure the well using lost circulation material, you can pump cement downhole and wait on cement, and then you can try to resume your drilling operation. Anyway, we have many techniques to cure the loss in the hole.
Okay.
So it can be low circulation material by adding some chemicals. It can be pumping cement on the bottom, for example, yeah.
Okay, thank you very much for the great webinar you did with us today, and thank you for the answers. And for sure, we cannot wait until we see you again on Sunday. We'll continue talking about drilling simulation as amazing stuff. Guys, we have a second amazing technical webinar today about hydraulic fracturing operations. It will be 7 p.m. Egypt time, so please wait for us. Thanks again, and have a wonderful day, have a wonderful evening, have a wonderful night. It depends on the time in your country now. Thank you.
Thank you, sir. Thank you, Dr. Ahmed.